Alright, this was the last example in the Tuesday slides that we didn't have a chance to do quantitatively. We qualitatively talked about it. We talked about what types of energies we have present at all of these points, but let's go through the work. Also, before you watch this video, please make sure you pause the video and try this example on your own. So, suppose the height difference between the points A and D is h. So, this height is capital H, and the coefficient of friction on the rough patch, this patch here, is some use of K, and we'd like to find the length that the box slides before it comes to rest. And we've defined our y equals 0 point to be here. We can honestly define it anywhere, it doesn't make a difference. Okay, so first thing we know is as the block slides through point A to B to C, we only have conservative forces acting on the block, which is force of gravity. We do not have any non-conservative forces doing any work on this system. So we have energy at point A is equal to energy at point B is equal to energy at point C. Then, as this block travels from point C to D, there is a dissipative or non-conservative force doing work on the system, which is friction. So there's kinetic friction in this direction, while the displacement is in the direction to the right. So there is some negative work done on the block or some energy lost. So if you might remember from class, we can write this as either energy at points A, B, or C plus the work done due to friction is equal to the total energy at point D, or alternatively, how I've written it here, is energy at point A, B, or C is equal to the energy at point D plus any energy that's lost due to friction going from any one of these points to D. Okay, so what we've done is, and I'm allowed to choose that whichever energy I want to write down. If I want to write down the energy at B instead, the only thing is it's a bit inconvenient to compare the last point to point B because we actually don't know what this height is. Also, we need to use point A first to then figure out what the velocity here could be, but we would need to quantify or know what this height is. And then, similar to point C, we know height here is 0, but we don't know how fast the block is moving. We could do a comparison between point A and C, figure out that velocity, then use EC to compare to the right-hand side here. But it's actually most convenient to just use EA on the left-hand side, and then compare that to the energy at D plus any energy lost due to friction as it gets from A all the way to D. And we know as this block gets from A to D, only this section is there a force that is non-conservative, where we're losing some energy. So at EA, the block is sitting at rest before it's let go to slide, so the energy is just mgh, and that h is the height above our y equals 0. And then energy at D is 0. Why is that? Well, we know the block is at y equals 0, so the potential energy at that point is 0. We also know that the block comes to rest. Well, then the kinetic energy has to be 0. So there's no mechanical energy in the block when it comes to rest at this point. So we plug in a 0 for that. And then we add on what energy we lost due to friction. And that is just F dot delta x. But since the force is in this direction, so you might ask, like, okay, so the force is in this direction, the displacement is to the right, so the angle between them is 180 degrees, so we should get negative work done. And yes, that is absolutely true. If you use this version of the energy conservation equation, you would get a negative amount of work done on the left-hand side. But if you choose to quantify that negative work done as energy lost, it's a positive quantity on this side that's quantifying how much energy was lost due to friction. And that energy is just force times the distance the block travels. And since they happen to be anti-parallel to each other, there's no cosine of an angle that needs to be included. All right, then we're being asked how far it slides, so we want to solve for x here. So we see that the mass and acceleration due to gravity cancel out, and solving for x, we get h over mu sub k.